Hi students, welcome to HSC Earth and Environmental Science and Module 8, Resource Management. This is video number 2, and we're going to have a look at another very important renewable resource, water. This time again we're going to be identifying Australian renewable resources and where they're located, but particularly we're going to be looking at water. In the previous video we had a little bit of a look at agriculture and also a little bit of a look at aquaculture as well, and in terms of defining aquaculture, aquaculture is defined by the Food and Agricultural Organization of the United Nations as the farming of aquatic organisms including fish, mollusks, crustaceans and aquatic plants, with some sort of intervention in the rearing process to enhance production, such as regular stocking, feeding or protection from predators. This can include, of course, building dams on river systems, and we'll have a look at that as we go through this video. Depending on the species being farmed, aquaculture can be carried out in freshwater, brackish water, or marine water. There's a number of different systems that can be used for aquaculture, including ponds, tanks, pens, and floating cages. Aquaculture can be extensive, semi-intensive, or intensive, depending on the level of input and output per farming area and the stocking densities. Intensive aquaculture involves intervention in the growing process, such as with supplemental feeding and water aeration. That's the sort of thing that happens with prawn farming, where extensive aquaculture allows for the stock to grow on its own using natural food sources and conditions like they do for oyster farming. Aquaculture can be used to produce a variety of species, including fish, mollusks, crustaceans, and aquatic plants for human consumption, or for producing ornamental species and other products such as pearls. Aquaculture can also be operated with other agricultural activities, forming an integrated aquaculture-agriculture system. An example of integrated aquaculture systems is the farming of fish in a rice field or an aquaponic system. Australia has the third largest fishing zone in the world, over 8 million square kilometres. And you can see from the map that there's a lot of different types of species that are part of that, particularly a lot of fish species that we find scattered around the country, but also some other interesting things like prawns and also things like pearls off places like Broome. Aquaculture is a very important industry, and it's one that's very closely related to water. But the subject of this particular video is water. And water is a very important natural resource. And of course, we're probably just about had enough of water as a resource at the moment. These are, in the estate that I live in, some special collection kind of areas where the water actually drains in, and you can see where some of the stormwater is coming through the drains and into these areas of collections. And this is a very important component of water called surface water. Now we know that the surface water's only got two places that it can go. It can either run across the surface into the rivers and lake systems, which is what it often does. When it ponds like this, some of it will actually move down through the soil layers and then reach the lower levels of the rivers systems that way, or it can evaporate. So the water that's sitting on the surface can actually be evaporated by the sun, which is actually out again today, and so that water can go back up into the atmosphere. So it'll either percolate through the soil, reach the water table and make its way to the sea, to the ocean, or it'll be evaporated. So these are the two kind of outcomes for water. And one of the reasons this is important is because Australia is or has been recognised as the world's driest inhabited continent. And so we have access to just over 1% of global freshwater resources. In addition, the variability in water availability across the continent is considerable. When we look at a bit of a map of the changes that are occurring or some of the trends that we see in total rainfall over the last 60 odd years, we get a bit of a picture of this variability. The fact that despite the fact that we have limited fresh water, most Australians do have ready access to water and one of the highest per capita usage rates in the world. The problem is this variability, and you can see across the northern part of the country, we have large amounts of water falling at a fairly regular rate. But in other areas, particularly some of the coastal regions where some of the major cities are located, we are experiencing much, much less falls in the amount of water that we're getting on a regular basis. And of course, the problem is not solved by intermittent flooding. So you can't have 3 months of drought and then a week of absolute smashing rain that just floods everything. And this is one of the problems that we're having at the moment certainly with some of our extreme weather events. We're seeing this sort of thing happening. No rain, and then just a huge amount of rain. We get like a month's rain in 24 hours. And this is a problem. This is creating some significant challenges for us. Now, while the rainfall in the tropical north is high for short periods of the year, the high demand areas in the southeast and the southwest don't have access to that water. At this point, we've done nothing to try and build any sort of piping systems to get some of this consistent water that's forming or falling in the north of the country into some of these areas in the south where it's much poorer, where there's just not as much. And poor old Tassie down here as well. You can see a couple of areas where there's a little bit more rainfall, but again, fairly dry. So when we're talking about water, we're talking about groundwater, surface water, and rainfall. And these vary greatly from region to region. And population growth and climate change are expected to make these disparities even more pronounced. So it's critical that the variability in Australia's water resources is both acknowledged, and generalisations about the state of Australia's water security nationally must be avoided to ensure policy measures are designed for local conditions. Despite the fact that Australia occupies 5.6% of the world's landmass, it receives little more than 1% of the available freshwater resources. And access to freshwater across the continent is inconsistent. But if we focus our attention on New South Wales, then we can get a little bit more of an idea of what's happening with some of this water. So here are the New South Wales river systems, and you can see very broadly from this kind of map that there's a number of different river systems that exist in this state. The problem is that the supplies of water to each of these river systems is inconsistent. Many of these river systems are drying up, or at least before recent rainfalls that have created floods, are experiencing or going through some of these cycles of drought and flood. This is making some of the agricultural areas, particularly west of the Great Dividing Range, which kind of runs down this sort of an area. So west of that, this side, is where a lot of the plainlands are, a lot of the areas where we have high agriculture, and these are the areas that are really struggling a lot of the time. Certainly they're struggling for consistent rain. They're struggling for consistent water source. So if you can't get the water from the rainfall that's coming down, then maybe you've got to look at something like the groundwater, like what's actually underneath the surface and how do we bring that to the surface. The greatest challenge, of course, with that is that we've also got a bit of a problem with salination. And salination is made worse by heavy periods of rain. The problem is that the salt actually sits in the soil, and that's not too much of a problem. But when the rain comes, the rain dissolves that salt and then takes it to some of these very complex river systems. And so therefore, that can create salty water in our freshwater river systems. That plays all sorts of havoc with the ecosystem of those river systems. So we have both plants and animals in complex relationships in these river systems, to say nothing of the agricultural systems that also depend on irrigation from particularly big river systems like the Murray, the Darling, the Murrumbidgee, and the Lachlan. And up here in the Hunter region, the Hunter River itself is a very, very large river system. And at the moment, if you look at the mouth of the Hunter River, you can see all of this rain that we've had has been depositing a huge amount of sediment. And you can actually see that sediment when you travel over, say, the Stockton Bridge. You can see a lot of that sediment that's going out into the ocean at the moment. And it's actually changing the colour of the water. That's how much there is. So these are the sorts of problems that we have associated with water. We can see that there's lots of fresh water in this state, but it's not consistent, it's not reliable in terms of rainfall. It's not always falling on the areas that we need it to, and so it's a very, very important resource that needs to be managed. And when we think about this final module that we're looking at in Earth and Environmental Science, we're actually thinking about how we manage these very delicate resources, these resources that maybe aren't as consistent as we would like them to be, and maybe are being overused at this point, and therefore we need to think about how we're using those, what sort of things that we can do to try and get our usage to be more in line with the supplies that we have, to put less pressure on the natural resources that we have in our state and in our country. But there's plenty more resources to look at yet, and we'll look at some of those in future videos. Thanks for watching.